Welcome back. Today is day 5 of our solving quadratics unit. Today we'll be completing the square when a is not equal to 1. This will be a quick lesson. Just a reminder, a copy of the handout is provided in the description so you can follow along. Enjoy. Oh yeah, it's that time again. We have some math problems here and we need you to do them now. Pause the video, complete the problems, and return to the video when you're done. Let's go over this do now. Now most of you are probably looking at this one, figure out what constant should be added to complete the square, and verify with the picture. You're looking at your term here and you see 12, so I know you're probably using that rule. 12 divided by 2 and then square it should be, that's 36, so that you should make 36 tiles. So most of you probably said the answer is 36. But I want you to verify with the picture so you can see that it doesn't work. So for instance, if I write, well, I have 2x squareds, so I have 2x squareds, and so I'm going to put 2x squareds down, and then 12x's. So how are you going to place those 12x's? I mean, if you put 6 on one side, 1, 2, 3, 4, 5, I mean, how are you going to build a rectangle? It doesn't look like you can even, you can even build a square out of this. So again, I gave this to you on purpose because you're not going to be able to do it. So this is not the answer. It's not 36. So then you're like, well, how do you do it, Duarte? Well, what you should notice is there's a constant here, 2. And what happens if I take that 2 out? So if I use the distributive property and I factor a 2 out, now I'm left with x squared plus 6x plus some constant. Now if I was looking at that problem, and now let's try it again. What if we took 6, took b divided by 2 and squared it? You're going to get 6 divided by 2 is 3, square it, and that's going to be equal to 9. Now, that means we would need 9 tiles. So let's see if this makes sense. See if we can draw a picture that makes sense with this one. Well, I can draw my x squared. There's my x squared tile. And then I have so I have that one done. Now I have 6 x's, so I'm going to put half of them on one side, half on the other side. Perfect. And then I'm going to need, for this little spot right here, I'll need 9 little tiles. So I'll need 9 tiles right there. And that makes a square. And what I really like about this is because there's a factor of 2 here, because we're multiplying by 2, that means we actually need 2 separate, so we can actually create 2 separate squares. And that's how you do this problem. So this problem, the answer was 9. So that's going to lead into what we're doing today. Is the main idea is that when we have a value here, when our a value, so when I have ax squared plus bx plus c, a is going to have to be 1 or else we can't complete the square, and that's what we're going to talk about today. All right, thank you. All right, so how do we do this problem? Solve by completing the square, round your answer to the nearest hundredth. So what we said from the little warm-up problem is that we need this value of a right here, we need that to be a 1. So a right now is equal to 4. If we could just change it to a 1, then we can do the problem like we did yesterday. So the easiest way to do this problem is just divide each problem by 4. Divide each part by 4, and look what happens. So now, what am I left with here? This is x squared. This is negative 2x, and this one is negative 19 over 4 is equal to 0. All right, perfect. Now, this problem looks like yesterday, except for we have a fraction there, but we'll deal with that one. So how do we do this? Let's make some space here. So x squared minus 2x, create some space, is equal to 19 over 4. And that's a 4, sorry. All right. And what is the constant that I need so I can complete the square here? Well, take b divided by 2, so take negative 2, and that's from right here. So take negative 2 divided by 2, and then square that value. So it's not writing nicely over here. All right, so that's going to be negative 1 squared. What's negative 1 squared? Negative 1 times negative 1 is just positive 1. So this will just be positive 1. So I'm going to add 1 here, and I'll add 1 here. It looks like we're going to have a little bit of fraction work, but not too much. So help me out over here on the left-hand side. This will just be x subtract 1 times x subtract 1. And if you don't like fractions, we should know that the 1 can be written as 4 over 4. So I'm just going to write that as 4 over 4. So now this really becomes 23/4. All right, perfect. We're almost done. So this is x minus 1 squared is equal to 23 over 4. And then how do we solve this problem? Just like yesterday, take the square root of both sides. We have two answers, a plus and a minus. So I'm left with x minus 1 is equal to plus or minus the square root of 23 over 4. We could simplify that if we wanted to, but I'm not going to do that because I can just leave my answer as 1 plus or minus the square root of 23 over 4. Now, if you want to simplify that, go ahead. You can take the square root of 4, which is 2. But I'm going to leave it like that. Now, what is the approximate answer? So again, you can type this into Desmos. That'd be a good place to find out, well, what is that? What's the value actually? And one of them is going to be 3. Round that up, so 3.40. Or my other answer for this problem is negative 1.4, also round that up. All right, so these are my approximate answers, and this other one is my exact answer. So let's try problem 2, same idea. Let's make the a value equal 1, so let's divide by 3 on each side. So I'm going to divide every single, oh, this one looks like it's going to be a fraction also. That leaves me with x squared plus 6x plus 5 is equal to 0. Okay, not too bad, but now our a value is 1, so now we can complete the square. So that means we're going to take our b value, so take the 6, divide it by 2, and then square it. And what do you get? 3 squared is 9. Oh, hold on, I skipped a step. Create my space. I always like to create my space. I just got in the habit of making room so I can complete the square. So make some space there, and we'll have a negative 5 over here. But the value that we need to add to both sides, this is equal to 9, so that I'm going to add plus 9 to this side and add 9 to this side of my equation. Hopefully you'll start getting faster at these. These are just perfect squares, trinomials. So this is x plus 3. And this is negative 5 plus 9, which is 4. Oh, that's beautiful. That worked out nicely. I love it when that happens. So we get x plus 3 squared is equal to 4. And now let's finish this bad boy up right here. Plus and minus. X plus 3 is equal to, I'm actually going to take the square root of 4. What's the square root of 4? That's just 2. So I'm going to go plus or minus 2. And we are left with x is equal to negative 3 plus or minus 2. Now I would never leave my answer like this because I actually can add 2 and subtract 2 nice and neatly with no calculator. So my answer for this one is just going to be, one answer is whatever the value is, x equals negative 3 plus 2, which is just x equals negative 1. And the other one is x equals negative 3 minus 2, which is negative 5. And we're done with that problem. Perfect. That was a beautiful problem. All right. Try the next ones on your own. Try 3 and 4, and then so pause the video. Try 3 and 4 on your own, and then resume when you're ready. So what makes this following equation difficult to solve using completing the square? Well, I mean, when I first look at this problem, it doesn't look like it's challenging. We notice that a is 1, so that means we can just complete the square as is, so let's do that. And let's see, where is the problem going to come? So we have 7x, create the space, move the 9 over, so that first step was not hard. That's the same thing we've been doing. But now we're going to take b, we're going to divide it by 2 and square that value. So we're going to take b, which is 7, so 7 divided by 2. We're going to square that, and we're going to get 49 over 4. And now what do you notice? What the value we need to add to complete the square is going to be 49 over 4. So we're going to add that to both sides of my equation. Now, what makes this difficult is that you're going to have to factor this now. But my question is, we've never had a fraction as this term right here. And why all of a sudden do we get fractions? What's making this difficult? So again, what we should be noticing is, like, why did this give us a fraction this time? Well, we always have to take b, and we have to divide it by 2. So when we took 7 divided by 2, you're going to get a fraction. That doesn't go in evenly. And now we can kind of generalize that to all numbers. So what we should know from this problem is completing the square. Sorry, that's messy. Is difficult if b is an odd number. That's what we should know from this. So again, later on we're gonna we have one more method for solving. Actually, we have a couple of ways, but we have another method for solving quadratics. And what I would say is, when you notice b, when you notice your middle term here is an odd number, I wouldn't even use completing the square. I'd be like, you know what, I don't even want to try to do it. I'm going to deal with it. I'll find another way of doing it. And we will have another way. But just to complete this problem, just so you can see, when you factor this, it would be x times x, and then we would get plus 7 over 2, and another 7 over 2. And then this over here, we'd have to get a common denominator, and look at the work we have to do just to do this. So that would change. So I would change this to a 36 over 4, and then we'll add in the 49 over 4. Like, look at the work I'm doing. This is just annoying me. There has to be a better way, a faster way of doing this problem, and we'll see that later on. So equals, what is that, 13 over 4, and finally we'll take the square root. So again, sorry, this one got messy. My tablet's bugging me right now. So we get you get x plus 7/2 is equal to plus or minus the square root of 13/4, and x is equal to -7 plus or minus square root of 13/4. So again, we can still do the problem, but it's annoying. It's a lot of little work, a lot of tedious fraction work, and there is another way you can do that problem that's going to be nice and quick. We'll learn it probably tomorrow. All right, thanks for watching the video, and enjoy.